So let's continue with the second subtitle. The first one was graphing points in 3 dimensions. Now we're gonna talk about graphing linear equations in 3 dimensions. And guys, this is also similar to the idea of graphing linear equations in 2 dimensions. If you remember, you learned this in grade 10. Maybe some of you remember. Let me remind you. In 2D, let's say the example is x plus 2y equals 4. So if you're asked to graph this equation, linear equation, how do you graph it on the two-dimensional coordinate system? Do you remember? There will be students who remember. Let me remind you. You know what linear equation is? It gives you a straight line, either increasing from left to right or decreasing from left to right or horizontal or vertical, right? So here, you should know what x and y intercepts are first to sketch the graph, right? So you should know your x-intercept. In order to find x-intercept, you let y to be 0. If y is 0, x plus 2 times 0 equals 4. So x plus 0 is 4, x is equal to 4. So 4 is your x-intercept. So on the x-axis, you plot 4. What about y-intercept? You do the same. To find y-intercept, you let x to be 0. When x is 0, 0 plus 2y is 4. Divide both sides by 2. Y is equal to 2. So on the y-axis, find 2. So you have 2 points. All you have to do is connect these 2 points. So here is your graph. This is how you graph a linear equation in 2 dimensions, right? Does it ring a bell now? Okay, now in 3 dimensions, we're gonna do exactly the same. We just have an additional z. We will do these steps for z2. Everything is same. We just have an additional z coordinate. So let's start solving this question. Graph the linear equation 3x plus 4y plus 2z equals 12 in 3D. So let's find intercepts first. So x-intercept, meaning the rest is 0. Y is 0, z is 0. So 3x plus 4 times 0 plus 2 times 0 equals 12. So by finding x-intercept, we mean y is 0, z is 0, okay? The rest is 0. So 3x plus 0. 3x is equal to 12. Divide both sides by 3 to isolate x. So x is 4. So you plot 4 on the x-axis. On the x, be careful. This is the x. 1, 2, 3, 4, you are here. Plot your point on the x-axis. Now, do the same for y. So, what is the y-intercept? Y-intercept. This time, the others are 0. X is 0, z is 0. So it's going to be 3 times 0 plus 4y plus 2 times 0. So if you are asked to find y-intercept, if you are required to find y-intercept, you should keep y. If you are required to find x-intercept, you should keep x. The rest is 0. You are finding y, the rest is 0, equals 12. So 0 plus 0, 0 plus 4y, 4y, 4y equals 12, and you need y alone. Divide both sides by 4. Y is 3. So this is the y-intercept. So find 3 in the y-intercept on y-axis. Sorry. 1, 2, 3. You are here. Okay. Let's do the same for the intercept. And this time, as you can guess, the rest is 0. What are the rest? X and y are 0. The other variables are 0. So 3 times 0 plus 4 times 0 plus 2z equals 12. 2 is additional. We have 2z here. Divide both sides by 2 to isolate z. So z becomes 6. Now, let's plot 6 on the z-axis. 1, 2, 3, 4. Let's say z6 is here approximately. 6 is here approximately. 3 is here approximately. And 4 is here approximately. Now, what was the last step into the connecting the points? Now, we will do the same. Just connect the points. Let's connect the points. Can I use straight lines? Let me see. Maybe I can. Yes. Yes. And 4, 2, 3. Yes, here it is. This is our answer. This is how we graph a linear equation in 3D. So this triangular plane figure will be the graph of this linear equations in 3D. Easy, right?